This video is going to look at the different ways that psychologists investigate the brain. So we look at your specification, there's 4 key ways of investigating the brain you need to know about. Functional magnetic resonance imaging, electroencephalograms, event-related potentials, and post-mortem investigations. For the first 3, you can learn the shorthand for them. As long as you're able to recognise what those words would mean in the exam, the shorthand will be fine. So we're going to look at the AO1 first, what these things actually are. So you'll need to describe what they are and be able to identify which are which if you were given them in maybe a multiple choice question. So the first one we're looking at is the fMRI. So a lot of you will just know these as MRI scans. And there's a picture at the bottom which shows you what these look like. And what MRI scans look at is they can detect the blood flow and oxygenation in the brain. Okay, that occur as a result of brain activity. The more active the brain is, the more oxygen it uses, the more blood is directed to that particular area. And it works by using radio waves and a magnetic field, hence the M in magnetic from MRI. And what we can produce with an MRI is 3D images. So we can get a 3D image of the brain, which shows us which parts of the brain are going to be involved in different mental processes. And it's really important for when we're trying to look at things such as the localization of function. Because if we're trying to find what parts of the brain maybe are involved in language, like the Broca's area or Wernicke's area, then we're going to be hoping those areas are showing far more activity because they're the language centers of the brain. The next one we're going to look at then is EEGs, and you can see the picture here. It's using electrodes attached to the scalp via a skull cap. Okay, so the person will be doing one here. I did many of these as a research participant while I was at university, involved in sleep studies. Someone will come around to my house before I go to sleep, attach this to my head, and you get paid quite a bit of money as a student just to have your radio waves and electrical activity all measured while you're asleep. And the scan records brainwave patterns, okay, generated by all the neurons in your brain. Each of these little electrodes will be measuring your brainwave patterns. And it records the overall account of the brain activity. So when you're asleep, it will look at the brain activity then. When you're aroused or awake, it will look at the brain activity there as well. ERPs are elicited by specific stimuli presented to the participant. So we get the EEG reading that we just looked at, and we filter out all of the irrelevant information from that. So we present the participant with a specific stimulus, and we're able to pick out that particular part of the EEG. So remember, the EEG is just showing you general state from asleep to awake, a big graph. This ERP now, we present them with a specific stimulus. It might be a loud noise or flash of light, and we can zoom in on that particular section. When the light flashed, right, let's look at the brain activity at that particular moment. Okay, and these brainwaves then are triggered by these specific events. We've also got post-mortem investigations. Post-mortems are analysing someone's brain following their death. So it's likely to be someone who's had either a really rare disorder or experienced something unusual that's developed into a mental disorder. So the areas of the brain that have been damaged are usually investigated or examined to try and establish the cause of that disorder. So an early example was Broca's work that we learned about with his patient Tan. Remember, he had speech problems, couldn't speak, could only say the word Tan, but he could understand language. And when they analysed his brain and examined his brain when he was dead, so they take the brain out, examine it, they found there were lesions on the left-hand side of that frontal lobe. And that was eventually named Broca's area. So now we're going to look at the area 3 for each, the strengths and limitations of these 4 different ways of investigating the brain. So the first one is fMRIs. And the strength of it, it doesn't rely on any radiation. So it is virtually a risk-free way of investigating the brain. You go into one of the big tubes, it uses magnetic fields, and you get that 3D image. It's also very non-invasive. You don't have to go into anyone's brain in order to actually get the image at all. And that means overall it's a very straightforward method of measuring activity. The images can be exceptionally clear. That 3D image provides you a very clear image of what's going on in different parts of the brain. But the weakness is that it's very, very expensive to actually run and put someone into an MRI machine. And the image is only clear if someone stays perfectly still. Any movement will completely distort the image on the MRI. And finally, it can only measure blood flow, so we can't zoom in on any of the neural activity or neurons that are working in the brain. We can only look at oxygen and blood flow. So EEGs, remember that skull cap with all the different electrodes all around your head. The strength of this is that it's a very safe and non-invasive way of measuring brain activity. There's no surgery involved, you're not going to go into the brain, but you're still able to put all the electrodes on different parts of the brain to measure activity in those different lobes. And it's great as a way of measuring activity in those different lobes. Okay, you'll have some on the back in the occipital lobe measuring activity there, some on the parietal lobe at the top, the frontal lobe, your temporal lobe. You're able to measure activity in all of the different lobes because of all the various electrodes on the skull cap. And it's often used as a diagnostic tool, so it's able to help diagnose people who have epilepsy, because you'll see random bursts of activity will be very clear on the screen. And like I mentioned earlier, it helped an awful lot in our understanding of sleep. Sleep time we're going to look at in a lot more detail later in the course. But there are some weaknesses. Okay, it does lack precision. It gives you a general state during sleep or being awake, but it doesn't actually hone in on any individual neurons or it's not really sensitive enough. The electrodes aren't going to be sensitive enough to give us information on particular sections of the brain. Okay, we can't work out individual action potentials or individual electrical activity from the neurons. So ERPs now address all those limitations of the EEGs, okay, because they bring specificity. They make it far more specific measurement. One of the key sensors is that it has excellent temporal resolution, so there's very little lag between what happens, so we flash the light, and what we see on the screen. It's almost instant. As soon as you see the flash, the spike in the screen will be seen. And we can link this ERP graph, like the one you can see down here, we can link that to specific cognitive functions. We're able to say, right, it's done the flash of light, right, that's something visual. Where have we seen that in what part of the brain? And the electrodes in that part of the brain will then tell us that part of the brain is linked to the flashing light. So we're able to link it to specific functions in our brain. However, it does have weaknesses. There is a lack of standardization in the studies that use it. Not all studies use ERPs in the same way. And therefore, to establish any pure data, one of the major limitations is that it's got to be absolutely no background noise whatsoever in the laboratory. If there is any background noise, that might distort or change any of the little electrical currents that we will be seeing on the graph. So we might not be getting a true picture of what's happening because of things such as background noise. We've also got post-mortem investigations. So the strength of this is that it was absolutely amazing for understanding an early understanding of brain processes. You look at the work by Blocker and Winnick that we've already looked at in previous lessons, and post-mortems were what allowed us to establish the link between our brain and language, what parts of the brain were actually involved. And the whole benefit of that was that set up the whole area of psychological research. Certain parts of the brain had certain functions. However, there are weaknesses. Okay? Sometimes it's not clear whether the resulting mental disorder, for example, was down to damage to the brain. It could have been down to any other reason. So Barocca did find the lesions on the left side of the brain, and those people generally had language difficulties, but it may have been a different reason. There's no cause, it's hard to establish cause and effect with that particular issue. And also there's a lot of ethical issues when we're talking about mentally ill patients. Are they able to actually give their full consent to having their brains being examined? So there is that ethical issue regarding consent. Are they in a fit state of mind to actually give their full consent to have their brain examined.